Hello, I'm Mr. Singleton, one of the Associate Directors for Science for Outward Academy, and this lesson is for triple students only, so only if you are doing GCSE Physics. If you are doing combined, you do not need to worry about this lesson. And we are just improving on what we did last lesson about pressure and volume and constants. We need to know what pressure is measured in, how to work out volumes, and then the effect of changing those. And then at the bottom here for high tier only, what work done is and how doing work on gas increases the internal energy and so can change the temperature. Two very quick questions, just using this diagram up at the top here where you've got A and B, and one has a high pressure and a low volume, which is A, and then one has a lower pressure and a high volume. So which cylinder has the most particles, and why do you think A has the highest pressure? I'll give you 2 minutes to have a think about it. Okay, you got 30 more seconds. Hopefully by now you've worked out that neither of them have any more particles in. They've both got 9 particles in. But why is it that A produces a high pressure? Well, it's because the volume is much lower. So if you're doing this in your book, write pressure in gases. If you're doing this on a revision card, again, pressure in gases. Date and title. I'll give you 30 seconds. Off you go. So the challenge today is to describe how changes in volume and temperature affect the pressure, which we should be okay with. Really, it shouldn't take too long. And then explain how changes in volume and temperature affect the pressure of a gas. So what causes pressure? This is just a bit of a recap from last lesson. What causes the pressure in a closed system? How does increasing the number of collisions affect the pressure? And then why should you never heat a sealed tin of beans in a cooker? Okay, so just this is a recap from the last one. So what causes pressure in a closed cylinder? That is just the collisions between the wall. How does increasing the number of collisions affect the pressure? The increase in the number of collisions means it increases the gas pressure. And why would you never heat a sealed tin of beans on your cooker? That is because the pressure would increase and the can would explode, which would be ridiculous. So how does volume affect the pressure of a gas? So for a fixed amount of gas and a constant temperature, so we're not changing the amount of gas in there or the number of particles in there, and we are not changing the temperature, the pressure is what we call inversely proportional to volume. So as the volume decreases, what happens is your pressure will increase. So volume decreases, pressure increases. If pressure increases, then volume must decrease, etc., etc. So what happens to the pressure of gas when the volume decreases? Why is the temperature kept constant? And what do we mean by inversely proportional? See if you can draw a graph. It's the same as what it's like in maths. I will give you 2 minutes. Off you go. One more minute left. So the answers for that previous slide, what happens to the pressure of a gas when the volume decreases? Well, then the pressure will increase because what you're doing is you're squashing those same number of particles into a smaller space. Why is the temperature kept constant? And that's because temperature will affect the pressure. If you increase the temperature, then that will increase the pressure. If you decrease the temperature, that will decrease the pressure. So you have to keep those constant. And then what does inversely proportional mean? It basically means as one goes up, the other bit goes down, basically, if I'm putting it into layman's terms. So as one thing increases, the other thing decreases. And that's what inversely proportional would look like on a graph. So I'm going to ask you to have a look at these 4 questions. So what's the temperature of each gas? So there's 2 different situations on this diagram. You've got the left-hand side situation, you've got the right-hand side situation. So I want to know what is the temperature of each gas, what is the volume of each gas, what is the pressure of each gas, and then can you see the relationship between volume and pressure? I'll give you 1 minute to have a quick look at it all, and then we'll try to go through it and make some sense of it. Off you go. Okay, so if we look at the gauges, what is the temperature on each side? Well, this time it's Kelvin, but it's 300 Kelvin in both circumstances. So both of them say 300 Kelvin. What is the volume of each gas? Now, the first one on the left-hand side of your screen, the volume is 4, but on the other side, the volume is 2. And now we can see that because the volume's changed, that's had an effect on the pressure. So when the volume is 4, so when the volume's higher, the pressure is lower, it's at 1. Whereas when we decrease the volume down to 2, the pressure increases to 2 instead of being 1. So what can you say about the relationship between the pressure and volume? Well, as you increase the pressure, you decrease the volume. And as you decrease the volume, you increase the pressure. So this is how the graphs, or what the graph would look like. And this is a inversely proportional. So this is Boyle's law, and it describes the behavior of gases. So when gases are put under more pressure, their volume decreases. And that's because the particles are forced to be much closer together when there's more pressure. But then the opposite of that's true. So as the pressure decreases, the volume then increases, and that is an inverse relationship. Okay, and this is how we show it. But if we change anything, so if we change the temperature, then we're changing lots of different things, and it gets a lot more complicated. So I want you to have a look at these 3 questions. What happens to the pressure of a gas when its volume increases? What relationship does the graph show between volume and pressure? And what is pressure measured in? 3 questions, 3 minutes, off you go. You've got 30 more seconds. Okay, so what I can hope you can see from the table, what happens to the pressure of a gas when the volume increases. So as the pressure what happens to the volume, when the volume, The last little bit of this lesson is about work, and it's related to this gas pressure a little bit. So we'll just recap what work is. So work is a transfer of energy by a force. So if I'm pushing something, and it will transfer energy by that force. So I'll give you some examples. If I'm pushing a car against friction, then that is an example of work, because that car will then increase in kinetic energy. If I lift a fridge against gravity, then as I lift the fridge, it increases in its gravitational potential energy. This also applies when you are squashing or decreasing the volume of a gas. So if I put in pressure, if the pressure is increased, work's being done on the gas, and that energy will have been put into the gas. This energy will try to raise the temperature of the gas. So this is known as the first law of thermodynamics. So as I push down into a can, or I try to squash a can, then I'm putting in work, and that energy will go into raising the temperature of the gas. So let's just try and see if we've fully understood that with some examples. I just want you to think, is it a yes or is it a no if work is being done on the gas or not? So a football being squashed. What is that an example of work being done? Yes, it is, because you are putting on a force, and that will increase the temperature slightly of those particles. The top being taken off a fizzy bottle. Is that example of work being done? Well, no, it's not, because the gas will escape and it won't increase the temperature. A bike tire being inflated. Is that an example of work? Yes, it is, because again, those particles will increase in kinetic energy. A balloon being popped is not, because those particles won't increase in energy. Back to the sealed tin of baked beans being heated. Is that an example of work being done? And that's a no, because you can't change the volume. The volume won't change at that point. That's the hard. So if you are doing a revision card on this last little bit, then if you decrease the volume in a container, then the pressure will increase. The particles have less space. As you increase the pressure in the container, you increase the energy in the system, so the temperature will also increase. And then there was that equation, which is pressure times volume equals a constant. Now that constant is not a constant that is the same number for every single situation. All it's saying is that as you increase the pressure, let's say the constant is 20, as you increase that pressure, then the volume must come down, because it's always going to equal 20. So let's say the pressure was 1 and the volume was 20. If I increase the pressure to 10, then the constant still stays at 20, so the volume must have come down by 2, because it's pressure 10 times 2 equals 20. So it's just as one increases, the other one has to decrease, and that could, because it's always a constant. That is the end of this lesson. Well done. Keep on going. If you need to go back, this is on YouTube. You can go back if you didn't quite understand something, but well done.